Hi friends, everything that you see around you is called matter. Matter is made up of tiny particles. Do you know how tiny these particles are? For example, how many sugar particles are present in a single grain of sugar? The answer is coming up in this video. We'll explore the characteristics of particles of matter by doing some exciting experiments so that you can get a visual feel of it. For these experiments, I'm going to be using some simple everyday things so you can try them yourself. I'm sure by the end of the video, the concepts are going to be super clear to you and you'll find it easy to remember. And then we'll finish off with our top 3 test-oriented questions on this topic. There were 2 competing theories regarding matter. One said that matter is continuous, and the other says matter is made up of tiny particles. Now, which one do you think is correct? Science is all about validating theories with experiments. So let's go to our experiment table and check which theory is right. Here we have some sugar and a glass of water. Can you see these sugar grains? Now when I dissolve it in water, where does all the sugar disappear? Why is the sugar not visible anymore? And if I taste this water, it tastes sweet. So there's definitely sugar in there. The reason is the water broke up the sugar into tiny particles. So tiny that it's not visible to us. So which theory do you think is correct? That's right. Matter is made up of tiny particles. In this video, we are going to be discussing these 4 characteristics of particles of matter, which are particles of matter are very small. They have spaces between them. They are continuously moving and they attract each other. We are going to understand each characteristic with the help of experiments. Let's look at the first characteristic. Particles of matter are very small. Let's try an experiment to prove this. For that, I'm going to take a very small quantity of potassium permanganate crystals and we are going to dissolve it in 100 ml of water here. Can you see that deep purple color? Now if we can show that a very small quantity of potassium permanganate can also color a large volume of water, then that means that these crystals must be containing millions and millions of particles that get spread on dissolving and color the water. So the particles of potassium permanganate must be very small. But the trick we are going to do is, rather than dissolve a small quantity of potassium permanganate in a large volume of water, we are going to make use of the purple water here. So we are going to take a small quantity of this purple water and dilute it with more water. And then again take a small quantity of that and further dilute it with more water. It's the same effect as adding a small quantity of this in a large volume of water. Let me show you how. First, I have taken 1/10 of this purple potassium permanganate solution in the small beaker here. So 1/10 of 100 ml is, as you can see, 10 ml. Now I am going to pour this solution into the empty glass here. And then we are going to dilute it with 90 ml of water so that the total solution becomes 100 ml. So can you see the light purple color now? Now let's take 1/10 of this new solution and again dilute it with water to make the total volume 100 ml. Again we have taken 10 ml of this light purple solution and we are going to dilute it with water again. So the total volume of the new solution is 100 ml. And can you see the pink color of the solution? And again we are going to repeat the dilution process with this new solution. So even in this last glass, can you see that that light pink color is still visible here? So this process of taking a small part of the colored solution and repeatedly diluting it makes the color go from dark to light. With the help of this experiment, we've shown that if you take the same small quantity of potassium permanganate and put it in a large volume of water, you're going to end up with a light pink color like this last glass here. So what's our conclusion? These tiny crystals of potassium permanganate must be containing millions and millions of potassium permanganate particles, which on dissolving in water, they can spread through the large volume of water and give it a light pink color like this. So the particles of matter must be very, very small. Similarly, a sugar grain is made up of a large number of tiny sugar particles or sugar molecules. Remember, I asked in the beginning of the video, do you know how many sugar molecules are present in 1 grain of sugar? So 1 grain of sugar like the one I have on my finger here. So what's your guess here? Is it 1,000 sugar molecules? Or maybe 1,000,000, 1,000,000,000, 1,000,000,000,000? Or is it 1,000,000,000,000? That's right. The correct answer is 1,000,000,000,000. That's 1 and 18 zeros. To help you visualize how much is that, I want you to pause the video here and go and get 1 grain of sugar from your kitchen. So are you ready with your sugar grain? Now look at this sugar grain and say this sentence. There are more sugar molecules present in this single grain of sugar than the number of sugar grains produced per year in the entire world. Unbelievable, isn't it? But it's true. So if you take each sugar molecule in this sugar grain and convert it to a sugar grain, you'll have more than the entire world's sugar. And there, I just ate a quintillion number of sugar molecules right now. Let's place the first characteristic, particles of matter are very, very small, on our concept board. Now let's take a look at the second characteristic. Particles of matter have spaces between them. I'm going to immerse this spoon into this glass of water, and you carefully observe what happens to the level of water. As you can see, the water level rises a bit. The rise in water level is going to be much more clear if you use a larger object. Now I'm going to put the sugar grains in water, and you carefully observe what happens to the level of water. We are going to dissolve this sugar in water. Once we stop stirring, as you can see, there is no rise in the level of water. Why is it so? It's because these sugar grains break up into tiny, tiny sugar particles when they are dissolved in water. And these tiny sugar particles go and occupy the spaces between the water molecules. That's why the level of water does not show a rise. So this experiment proves that particles of matter have spaces between them. Now let's visualize this scenario. So imagine we zoom into this glass of water a million times. So how is it going to look? It'll probably look something like this. These white balls here represent the water molecules. And when we put the sugar grains into water, each and every sugar grain is going to look like this gigantic ball compared to these tiny water molecules. So let me put this sugar grain into water. Watch carefully, because this huge sugar grain is going to soon break up into tiny sugar particles, represented by these tiny red balls. As you can see, these tiny sugar particles go and occupy the space between the water molecules. Let's spin the second characteristic. Particles of matter have spaces between them on our concept board. Now let's move on to the third characteristic. Particles of matter are continuously moving. This means that the particles are in continuous motion and on their own. So you don't need to set them in motion. Let's take a look at a couple of experiments for this. I'm going to light the incense stick here. Can you see the smoke spreading on its own? There's no fan or wind in the room. Very soon, the smell will spread across the whole room. This is because the particles are moving on their own. Let me show you another experiment for this. I'm going to drop some potassium permanganate crystals into water, and this time I'm not going to stir it, but I'm going to let it dissolve on its own. Can you see the purple color spreading on its own? So both these experiments prove that particles of matter are continuously moving. Once again, we can visualize the dissolving of potassium permanganate in water by using our bowl of water molecules here. So when we drop the potassium permanganate crystals into water, they break up into tiny particles like this. And since the particles are constantly moving, they spread across the entire liquid. In both these experiments, you can see that particles of different types are getting mixed up. Here it is the smoke particles and the air particles. And in this case, it's the potassium permanganate particles and the water particles. Now, what is the process of mixing up of particles of different types known as? That's right, it's called diffusion. Now, what type of energy do these moving particles possess? That's right, it's kinetic energy. Let's put the third characteristic, particles of matter are continuously moving, on our concept board. Now let's take a look at the fourth and last characteristic. Particles of matter attract each other. A simple proof is, can I break this metal spoon? Definitely not. Or can I break this table? Ow, looks like my hand is broken. So the particles of matter are attracting each other very strongly, and that's why we can't break these. But there are some other examples where the force of attraction is weak, like in this piece of chalk. For example, I can easily break this chalk, or I can cut through the water in this bowl, or I can easily cut through the air. So in these cases, the force of attraction between the particles is much weaker compared to the metal spoon and the table. So these examples show that the strength of the force of attraction is different in different substances. Let's place the fourth characteristic, particles of matter attract each other, on our concept board. Now that we are done with the 4 characteristics of particles of matter, are you ready for the top 3 questions on this topic coming up for you right now? Friends, go ahead and give these questions a try. And do post your answers and doubts in the comments below. I make a commitment to reply to your doubts as soon as possible. I'll disappear so you can pause the video here and try solving these questions. Isn't it amazing that this massive universe is made up of tiny, tiny particles? As we saw in this video, even a single sugar grain is made up of a quintillion number of sugar molecules. That's more than the number of sugar grains in the entire world. And if you enjoyed watching this video, be sure to hit the like button and the subscribe button for my channel. You can also follow my Facebook page. Thanks for watching.